And good morning. This morning, I just wanted to go over, just kind of review a little bit of atoms. We did have that reading assignment to go with it, but a lot of confusion. So I want to go over a little bit of that, and then also go over how to use the element builder gizmo, and we'll use that to kind of answer a lot of these questions here for our worksheet that kind of goes with this. First, so let me talk about um, atoms themselves in matter. Okay, all atoms are the smallest part of an element, and elements are what we're made of. As living things, we're primarily made up of carbon, and then bonded to that, we're going to have things such as hydrogen, oxygen, nitrogen, sulfur, phosphorus, things like that as well. But there's a bunch of different elements out there. We've got our periodic table, and there are about 111, 113 actually, with some of our synthetic ones, 118 different elements. And we'll kind of go into more detail later on about how to use this periodic table. A lot of information contained in here. I have linked this in the assignment as well, and I'll link this in the materials as well as far as the periodic table. This one's great. If you Google them, there's some other ones that you can get access to as well. Anyways, all the elements that we have, all the elements that exist, can be created using this. Now, recommend that you guys turn this on to show the element name, show the element symbol, and also show the notation. Okay? And so we'll kind of talk about what this notation means. But right now, if we're looking at a standard atom of hydrogen, right, this is actually going to have one proton, 0 neutrons, and 1 electron. Okay. Now, basically, this gives you the atomic mass and the atomic number. Okay, so it's going to have one hydrogen, and this one is going to be neutral. If I take away this electron, okay, this is going to be ionized, and notice how this has a 1 plus on it now. Because keep in mind, protons have a positive charge, neutrons have no charge, or they're neutrally charged, and electrons have a charge of 1. So notice when I add that electron, how this charge of plus 1, it's no longer ionized when I do that. So you can see I take away that electron, it's ionized, and an ion is any element that has a charge. And basically when it has a charge, that means it's going to have a different number of electrons than it does protons. Okay? And electrons are the only ones that we can change. If we change the number of protons, that becomes a different element. So I can add neutrons, and notice how this still stays hydrogen. Okay, right now it's still ionized. I can add that electron. Now it's not ionized anymore. We can change the number of neutrons. This gives us what are called different isotopes. And those are basically just different variations of an element that have different weights. And that's based off of the neutrons. So I'm going to go ahead and ditch these 2 neutrons here. But this is what a typical a typical atom of hydrogen would look like, with 1 proton, 1 electron orbiting around that. And notice, it says this is stable, and this makes up 99.985% of the element. Okay. Additionally, as we go to the periodic table, we can find this information on this here. So this number here, this is the atomic symbol. This number is the atomic number. This tells you the number of protons and the number of electrons that should be in there. And this number here, notice this is a decimal. This is the average mass of hydrogen. Okay, so the way we get that number when we're looking at it, this 1.008. Basically, if we go to the gizmo here, so this makes up most of it, this isotope here. But there are some amounts of, so 0.015% of this element has this extra neutron, and they call that deuterium. And then we can even have this heavier isotope called tritium, and see that actually has 2 neutrons, This one's radioactive instead of stable. That means it's going through decay um, and whatnot. But that kind of shows us that's where we get our 1.008. So this number here is an average based on the mass that the different isotopes have and how common they are. And typically we're just going to round this off for all our purposes. So if we actually, let's say we went to an atom of helium, okay? So helium, I'm going to add an extra proton, and this one's ionized, so I've got 2 protons now. Our mass is 4. I'm actually going to add an extra electron now so that this is stable. So this isotope makes up 99% of it. It's not ionized. This is electrically neutral. So this is kind of how it should look. If we look at this on the periodic table, right, and it goes across, we've got rows and columns. So this is 1. Helium's going to be 2 because it has 2 protons. And then it's also going to have 2 electrons to correspond with that. And its normal atomic mass is going to be 4. So we're just going to round off this 4.03. There are a few other isotopes that it has, but those are going to be pretty rare. But that's basically how we make that. And then moving forward, if we go to lithium, right? Notice when I change the number of protons, that forms a completely different atom. So now we've got lithium. And actually, if I go to the periodic table and I look at lithium, it's going to have an atomic number of 3, so it's going to have 3 protons, but its atomic mass is going to be 6.941. I can round that number off to 7. 7 minus this 3 for the mass of the protons gives me the number of neutrons. So 7 minus 3 would be 4. I would have 4 neutrons on a typical atom of lithium, and we can go check that on the element builder here. So we can go, all right, we've got lithium, it has a mass of 5, so that means I have 2 neutrons. Let's make it 3, 4. And looks like it's ionized, so I still need to add another electron, so I have 3 protons, 3 electrons. And you can see this isotope makes up 92% of the element. So we've got the normal, or most common variation of lithium here. Now, when we're looking at our worksheet here, so it's just kind of asking you some basic questions about these. But basically, we're gonna go through. So, and this will kind of ask you from this. So this gives you the mass number. This gives you the atomic number. Electrical charge. If it's blank, then it's neutral. If it gives you a charge, then that means that is an ion. But just kind of going through this, which number is equal to the number of protons in the atom? Number of protons, that's going to be my atomic number. So I would put 2 there. As far as how you can calculate the number of neutrons in an atom, you would take the atomic mass and subtract the atomic number, which is, and this mass number, we've rounded that off. But 4 minus 2 is 2. Or you could just say you subtract the mass, take the mass number and subtract the atomic number, and that will tell you the number of neutrons. And then as far as which particles has a positive charge, that is going to be the proton. Negative charge is going to be the electron, and no charge is going to be the neutron. Now, isotopes are variations of them. They can, of an atom or an element. They can have more neutrons or less neutrons. So stable isotopes of carbon, for example. We could go, now I don't expect you to necessarily randomly know that, but if you go to carbon, and maybe I don't know what the number is for carbon, I'm going to go through and look at it. Carbon is going to have an atomic number of 6, and its average atomic mass is going to be 12.01. So I can just round that off to 12. And honestly, that's pretty much going to be the answer there. I'm going to go ahead and make some carbon here, though. Notice how the symbol's changing. I'm going to add some electrons, so I make this neutral. Now, notice how this says radioactive. So I'm just going to change number of neutrons. Again, now I've got 5 neutrons. That's still radioactive. I get to 6. This one's stable. I go to carbon 13. Notice how this is still stable. I go to carbon 14. That's radioactive. Everything else, all the other isotopes are going to be radioactive. So we're going to get back to 6, but the 2 variations of carbon 14 that are radioactive, or excuse me, the 2 variations of carbon that are going to be stable are carbon 12 and carbon 13. Okay, I hope everybody can follow along with that. And they basically do the same thing for nitrogen and oxygen there. Now, on these ones, you're basically just getting some practice work in the gizmo though. So how many electrons are in a neutral atom of lithium? Okay, so if I can't remember where lithium is, I'm going to go look at the periodic table, and there's nothing wrong with that. That's why we have a periodic table. So lithium is going to be right here under hydrogen. It has an atomic number of 3 and an atomic mass of 7. So I'm going to take that information and go back to my gizmo here and make sure I remember the question right. How many electrons are in a neutral atom of lithium? I don't even need to use a gizmo for that, because I know if I have 3 positive charges, and I'll do this anyway, but if I drop my protons down to 3, I've got lithium. I know that I'm going to have 3 electrons to match those, always. And that makes it neutral, right? If I had a wrong, different number here, that would be ionized. If I had too many, or not enough electrons, that would be ionized as well. So protons and electrons are always going to be the same. And so then we get into some other ones. How many neutrons are in an atom of magnesium-25? So again, I'm going to jump to my periodic table. I'm going to look for magnesium. And sometimes you just have to search it. I'm really old. I've been doing this a long time, so I've had lots of practice. But yeah, you can kind of go through and look for it. Now this tells us we have 12 protons, and our normal mass is 24.3, which would round off to 24. But I'm just going to up my protons. I'm going to up my protons here to 12. And then my neutrons, notice on the notification, I've got to put my electrons in there just because that drives me crazy. Now it's stable. Now our neutrons, basically we have to get this to where this equals 25. So if I'm looking here, each time I add another neutron, that's going to get it all the way to 25. And notice, kind of take note too how these electrons go in different orbitals. But that's really all I have to do to answer those questions. And so they're going to ask you some different ones. So like when they say when an atom is charged, it's called an ion. How many electrons are in O2 minus, right? So that's going to be with our notation here. So if I didn't know, I could go check oxygen on the periodic table. Oxygen has an atomic number of 8. So I'm going to go back here. I'm going to change my protons to 8. And we're looking for a charge of O2 minus. Right now that would be 4, so I'm going to change that. And notice now if I have 8 protons and 10 electrons, this is going to be charged here. Now, we'll get back to 16 here. That's the normal version of oxygen. That's the most common isotope. That's 99.762% of what we're breathing in and out every time. But I can go through and figure out, so that charge of O2 minus, that tells me I've got to get 2 extra electrons. And so I can just kind of, basically what this gizmo does is it just gives you a chance to kind of manipulate things a little bit as you're going through. Now, here's where you basically just kind of go through and answer these questions. But you could, between manipulating the gizmo and then going back and looking at the periodic table, should be able to do the rest of them. But if not, that's okay too. Hit me up, message me on Schoology, or shoot me an email, and I will get back to you as soon as I can. It'll be a pretty busy weekend for me. I'll be up the mountain, so I may not be able to get back to you till Tuesday. But anyways, I hope that helps you guys, and let me know if you have any questions. Have a good weekend.